Okay, so for this one, we have an underground gasoline storage tank is leaking. The tank currently contains 600 gallons of gasoline and is losing 3.5 gallons per day. If the value of the gasoline is $2.51 per gallon, how quickly is the value of the stored gasoline changing? All right, so what we need to do is we need to kind of create two functions. So our first one looks like it should deal with gallons, and then it looks like it's also, gallons in a day, things like that. So let's call it uh, gallons and GT, so gallons per whatever day it is. And so that's going to be amount of gas in tank after T days. Because if we're losing so much per day, we start with that, but it's going to be gone down every day by 3.5 gallons. Now, the value of the gas, so let's call it V of, and each dollar is represented per gallon. So let's call it V of G. That's going to be the value of G gallons of gas. Okay. Now, now it says, how quickly is the value of the stored gasoline changing? Well, what is our actual function we're looking at? Well, we're looking at a compose function. We're looking at V of G of T, because we can plug that G into here and we'll have V of G of T. And so that means what we need to do is we need to find dV dt. So that's, we're going to take dV of dt. And the way we're going to do that is we're going to take dV dg times, and then we'll take dg dt. And when we do that, the dg's cancel, and we're left with that dv over dt. So what we need to do is figure out what dv dg is and dg dt. All right, so the change in value per gallon, well, it's 2.5 gallons or dollars per gallon. Okay, that's what this is, because it says that's the value. And it says we're losing 3.5 gallons per day. So then we're going to multiply that by a negative 3.5 gallons per day. And now if we notice, our gallons cancel, and we're going to have dollars per day, which is going to be our, oops, not eraser. We need a pen. Is going to be our dollars per day is going to be our change in the price of gas. So we're going to take 2.51 times 3.5, and that means it's going to go down negative $8.785 per day. Okay, so that's how quickly the value of the stored gasoline is changing. So that's how much we're losing per day, because we are losing that 3.5 gallons of gasoline every day from a leaky tank. So it kind of just shows you, over time that's going to be quite a bit. If you don't catch it, you're going to lose a lot of value. All right. Here we're doing some more composite functions. It looks like, right, the composite function and its derivative in terms of one input variable. All right, that works. So what are we going to do? Well, let's first think about what we have here. We have c of x is equal to this, x of t is equal to this. So it looks like we need to do c of x of t. So that's what we're going to do. So when we get done, we want dc dt. Okay. Now, can we take the derivatives of this? Yeah, c prime of x is equal to 6x, and x prime of t is equal to a negative 6. Okay, that's not bad. So now we just plug these in, and so we get 6x times negative 6. Wait a minute here. We're supposed to be in terms of t, and it's given us terms of x. So that means, hey, there's something wrong here. We do have a value here, and it's 6x, but we need it in terms of t, and so we have to plug in the x equals that. And so this then goes and gives us 6 times 4 minus 6t, and then times our minus 6. Okay. Now that then would be a formal derivative that we could use. That would be the derivative. Now we're going to start going and changing, up to this point we kind of kept things as they are here, but if we could simplify it, I think that's what we're going to start doing as well. So we'll have our original one here, and then we'll also say, well, we're going to take 6 times 6 is 36, and then we're going to take that times our 4, so we're going to get 144, and it's going to be a negative. So we can say, or we get a negative 144, and then we'll have 6 times 6 times 6, so that's a 216, and it's going to be a positive, and it's a T. And so, it's going to be, and this we can call that just, I guess that's what we'll just call it dc dt. And so this is also dc dt is equal to that. So we have two forms that are going to be legitimate from now on, kind of. And so, this one we can kind of work backwards easier. This one, that just gives us a whole new function. It looks like a linear type function, and that would be what we have. All right, so this one is going to come up with something we're going to be using, and it's called U substitution. And with U substitution, they didn't really mention it in the section, but because we have to do it really to get to our answers, we're going to talk about it a little bit here. And so what we need to do is, if we think about this, this is really 7 plus 5x to the 1 half, okay? Because we're just going to get rid of that square root. It's easier to work with the exponents like this. All right, so with this, we can't really just say, well, that's, like a B, that whole thing is B. Well, what we're going to do instead, we're not going to call it B, we're going to call it U. We're going to call this G of U now is going to be equal to U to the 1 half. And how do we get that? Well, we said our U in terms of X, because that's what it is, of X is equal to 7 plus 5X. So what we're doing is we're kind of splitting this apart. We're taking what's inside here, we're calling that the U function in this case. And then what's left after that is, if we replace that with U, that's U to the 1 half. And so that's going to be our G of U. So we're going to call it with a U. So this is kind of getting us into the U substitution. And if you took a regular calculus class, you would do a lot of this where we do U substitution with more complex numbers. But this is where we're getting into it here. And so we'll have those two values. And so can we find the derivatives of everything now? Well, G prime of U, well, yeah, we can find that. That's just going to be bring down that half. Then it's going to be U, and this to the negative 1 half. And our U prime of X, well, that's just going to be a 5. And here we have X prime of W. Well, that's going to be just 4e to the w, because when you take the derivative of e to the w, you get e to the w, and that's just a constant times it. So now we have to think about what we have here. So we kind of replaced this g of x with g of u. And so then we plugged in the u here. And then we're going to plug in the x here. So we kind of have this dg, and it's kind of plugged in. So we'll have a g of u of x of w. So that's kind of what our whole list of things is. So we want dg with respect to w. So that's going to be what we get to, because this is the original, and we want to take the derivative of that. Okay, so how are we going to get there? Well, first we're going to take dg with respect to u. Okay, now we want to get rid of that u, so how do we do that? Well, we take du with respect to x. Now we want to get rid of x and go to w, and so how do we do that? Well, we take dx dw. Okay, so now we have dg du. Well, that's this part. Du dx, that's this part. And dx dw, that's that. And so now we replace it. And what do we get? So we get dg du, so that's the 1 half, and it's u to the negative 1 half. And so then we take that whole thing times du dx, which is a 5, times the dx, which is a 4e to the w. Now notice we want this in terms of w, and we've got a u here, so we got to get rid of that u. So what do we do? Well, we're going to replace this with u, which is 7 plus 5x. So we're going to have 1 half, and then we're going to have 7 plus 5x, and then that's to the negative 1 half, and then times 5 times 4e to the w, and now I'm running out of room. Now notice we still have an x. We only want w's. So we have to now replace this with this. And so I'm going to take this up to the top. So now I'm going to kind of cut this like that. And so now I'm going to move up here. And so now I have my 1 half, and then I have 7 plus 5x, which is now 4e to the w to the negative 1 half, and then parenthesis, and then times 5 times 4e to the w. Okay, so now at this point, we do have our dg dw. So that really is dg dw. And again, this is the very most basic form of it. We haven't simplified or anything. That's what we would call probably our our initial answer that we would give. Now, can we simplify it? Yeah, we can. Um, Here we have a half and times that 4. So that if we take that 4.5, that would give us a 2. So 2 times 5, that's going to be 10. And then we have EW. Now, so that gets rid of that term, and that term. Now, this is to the 1 half. So if we take that over, 7 plus 5, and then times, well, 5 times 4, let's go ahead and just simplify that while we're at it. So let's keep down our work here by simplifying. 5 times 4 is 20, e to the w, and then now it's to the positive 1 half. So, that looks good, but what is to the 1 half? That's the square root. Now, do we always rationalize our denominators? Well, we're supposed to. And so what we would do is we'd multiply by the square root of 7 plus 20 e to the w all over the square root of 7. Yes, 7, wait, I'm going to rationalize it. Yeah, okay. Plus 20e to the w. And so then when I get done, what we have is 10e to the w square root of 7 plus 20e to the w over 7 plus 20e to the w. Okay, so that is where I would be at that point in time. And that's it's complicated and a lot of work, but that it does get us a final answer. And so this one cannot be simplified, so maybe I should circle both my answers in red. So we have that one in red, and we also have that one in red. So that would be like my first one, and that would be my most simplified possible answer I could get with that one. All right, so again, this is using u du and our u substitution. So we'll talk more about that. All right, so now we have one with signs. All right, so let's go back to purple. And so what do we have? Well, we have PT is that and TK is that. So it looks like what we're going to do is we're going to plug in T here. And so let's first find our derivatives. Well, the derivative of sine is cosine, so that's 7.9 cosine T. And T prime of K is equal to 3 times that, it's going to be 42K squared minus 24K. And that should give me what I need there. And what we're looking for is we had P of T of K. And so that was really 7.9 sine of 14K cubed minus 12K squared. So that was my original function that I have to take the derivative of. And so that means I'm looking for dp dk, because I'm going to have that and that. So top and then bottom. Well, how do I get there? Well, I'm taking dp dt, well, I found that right there, times, and then I have dt dk, well, I found that right there, and so I just take and multiply those. And then times 42k squared minus 24k. Now am I done? Well, except for the fact I have a t here, and I'm supposed to only have k's. So now I have to plug in t, which is up here, in place of that. And so that gives me 7.9 cosine of 14k cubed minus 12k squared, and then times our 42k squared minus 24k. And so if we're circling, first and second answers, that would be my first answer. That would be it. That would be my dpdk. Everything's in terms of k over here, and I've made sure I've done my derivatives, and so I just plugged them in, dp over dt, dt over dk, and I got that. Now, is that only answer we could have? No, because it looks like I could take 7.9 times 42 and negative 24, and so that would give me cosine 14, oh yeah, 14 k cubed minus 12k squared times, now I'm going to take 42 times 7.9, I'll get 331.8k squared, and then minus 189.6k. And now that is going to be the most reduced form for my derivatives. So I could say or that. And so that would be my second or most simplified form. Okay. And so both of those give me the derivatives for our PT of K. Okay. All right. So let's stop there and I'll come back for more.